Okay, class, this is lecture number 6. Last lecture, we talked about mean, median, mode, weighted mean, and percentiles. Today, we'll talk about quartiles and measures of variation, which are range, variance, standard deviation, and coefficient of variation. Let's go back to quartiles. Quartiles split the ranked data into 4 equal groups. Now, the data set are divided into 4, 25% each. 25, 25, 25, 25. Altogether, they comprise 100%, right? The first quartile is this region here. The second quartile is this region, while the third quartile is in this region. We have an example here. Find the first quartile. The sample data in ordered array are 11, 12, 13, 16, 16, 17, 18, 21, and 22. A sample of 9 elements. The first quartile is the 25th percentile. 25th percentile. So, find the 25 over 100 times 9 plus 1, which is actually that's 10. So this is 25 divided by 100 is 0.25, of course. Then times 10, that's 2.5 position. So here in this sorted array, the 2.5 position is after this one. This is 1, 2, and 2.5 is somewhere in between here. So use the value halfway between the second and the third values. The value halfway is 12 and 13. So you add 12 and 13 and divide it by 2. The half, what's half between them? So the first quartile then is 12.5. 12.5. Now here's a drill. The time, which is in seconds, that it took for each of 16 vehicles to exit a parking lot in downtown Cincinnati is this one, 106, 135, 100, 130, 153, 78, 141, 125, 169, 51, 72, 128, 116, 129, 101, and 139. Then compute the mean, the arithmetic average, the median, which is halfway, the first quartile, and third quartile for the sample data. Okay, remember this. This may come out during the lab exercise. Just take note of this drill. We will solve this in the you will have this in the lab exercise. Then Let's go now to measures of variation. Measures of variation, how data varies from the mean of the data set, the center. There are different variations. One is range, another is variance, another is standard deviation, and fourth is coefficient of variation. For range, it has also what is called interquartile range, to be specific, while variance has two different variance, the population variance and the sample variance. Always, class, if you notice, population and sample always are present. The population refers to the whole number of things that we are interested in, while the sample version is only a subset of that. Now, standard deviation also has population standard deviation and the sample standard deviation. Now, what is variation? What is variation? It's a measures of variation, give information on the spread or variability of the data values. How variable the data values are within the data set. How it is being spread from the center, always from the center. While the range is the simplest measure of variation. The difference between the largest and the smallest observation is the range. You have this in lab exercise 1, where I ask you to identify the minimum or the youngest author and the oldest author, and I ask you to take the range of ages of the authors, which is the maximum or the oldest in the case of age, the oldest author, minus the age of the youngest author. That's the range. In that lab exercise, number 1, the range of ages is 36, right? Because the oldest is 62 and the youngest is 26. The range is 32. Was it 32 or 36? But here, the range is 14 minus 1, which is equal to 13. The oldest here, the maximum value here is 14, while the minimum, the smallest value is 1. So 14 minus 1 is 13. The range is 13. Now, there's a disadvantage, or there are disadvantages of the range, because it ignores the way in which data are distributed. It doesn't take account into how data are distributed. For example, here, in this sample data set 7, 8, 9, 10, 11, there are 5 here from, actually there should be 12 here. Number 12 is missing, so that the range is 12 minus 7. The highest is 12, which is missing here, sorry. Minus 7 is, the range is 5. And here, I think it's somewhere here, is hiding. Yeah. This one is hiding. And I think this one is also hiding. Why are you hiding? So that should be it. Number 12 was hiding behind. 7 to 12, and 12 being the maximum value in the data set. Subtract it with the minimum, the smallest value in the data set. 12 minus 7 equals 5. And here also 12 minus 7 is also 5. It ignores the way in which data are distributed. You see here, number 12 has three counts. The frequency is 3. Here it is evenly distributed. Here it's not. But the range is still the same. It ignores the way data are distributed. And also it is sensitive to outliers, like the mean that we talked in the previous lecture. The mean was sensitive also to outliers, to extreme values. For example, here in this data, the extreme values are 1 and 5. Okay, they're the extremes. But the range here, because these are 1, will be just the same. The number of occurrences for 1 is just the frequency, or the number of occurrence for 1. The same as with 2. Same with 3. But when you make a frequency distribution of this, you'll see that the highest value is 5, still 5, and the lowest is 1. So that the range is 4. And whereas here below, from here up to here, the data almost look the same with this one above, only that the last value is extreme, very different, very high compared with the rest, so that the range is now affected from 4 to very different, very high, 119, because the highest is 120 and subtracted by the lowest value, that's 119. So it actually, the other values in between are not even there. There is no such sample in this case, but it is affected. It is sensitive to outliers. Now, to eliminate the problem of outliers, extreme values, researchers often use interquartile range instead. This has the ability to eliminate some outlier problems by using this interquartile range. It eliminates some high and low valued observations and calculate the range from the remaining values. So interquartile range is equal to the third quartile minus the first quartile. So how does it work? Interquartile range. We eliminate the first 25%. Remember, we in the quartiles, in the quartiles means 1/4, right? 1/4. That means we divide the whole data set by 4, and we get rid, or we ignore, the first quartile, the first 25%, and we ignore the highest 25%. So we have only the maximum, somewhere in between the first quartile to third quartile, so that the interquartile range is now 30, in this case 30, no, 57 minus 30, which is 27 only. We get rid of the, because outliers are often in this range, in the minimum and the maximum values. Now, variance. Variance refers to the average of squared deviations of values from the mean. The mean, katong sa center, the average of the squared deviation, if the numbers are squared, that is, if they are multiplied by themselves, the average of those refers to the variance. Now, there are two kinds of variance: sample variance and the population variance. Sample variance is calculated using this equation, or this formula: S square equals the total of all x sub I minus the mean, this one, x with the bar at the top, and the result is squared. You sum all of that from 1 up to the number of sample, and then divide that number by n minus 1. Well, the population variance looks similar actually, only that the population is symbolized by this Greek letter, and squared, and the difference is the divisor is not subtracted with 1. It's the whole population, the value for the whole population. That's the main difference. Then the standard deviation. The standard deviation, this is most commonly used measure of variation. and it shows variation about the mean or around the mean, and it has the same units as the original data. Again, standard deviation has both the sample standard deviation and the population standard deviation, which the difference of which is the divisor here is subtracted by 1, whereas here in the population wala siya sa kuhay og isa. Then the rest of the formula is the same except for the symbol. Now, here's a calculation example for sample standard deviation. Sample and not population. So, kung sample standard deviation, we use this formula na ay -1 ang divisor. So here, sample data for x sub I are these 10, 12, 14, 15, 17, 18, 18, 24, where n equals 8 because there are 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in our sorted data. And the mean of this, the arithmetic mean, this one, is 16. If you add all those and divide it by 8, that's 16. Now, to compute the sample standard deviation, you need the mean. You need the mean here, 16, the mean. Because we are calculating how a certain data deviates from the center of the sample. So the formula is this. We subtract the first element with the mean, and then we square it. We add it with the next element, again subtracted by the mean, square it, add the next, which is 14 minus the mean, square it up to 24, kini siya, minus the mean and square it. Now, divide it all over by n minus 1 because this is sample. Here, by substitution, the mean is 16. So 10 minus 16 plus 12 minus 16 plus 14 minus 16 plus up to 24 minus 16. 16 is the mean. So if you add all those, it is 126. If you square the number after subtraction and you add them, that's 126, and the sample size is 8 minus 1 according to the formula, and square it, get the square root. So the square root is 4.2426. In other words, the standard deviation can be thought of as a measure of distance from the mean, or how far is an element or a sample or a value is from the center of the sample. For example here, dataset A, dataset B, dataset C. Dataset A has this data 12, 11, 12, 13, 16, and frequency is 2, 17, 18, and 21. The mean of those, if you add all this, wala abot ng blanco, the mean is 15.5, and standard deviation using this formula here is 3.338. 3.338. While data B the frequency looks symmetrical here, symmetrical. This one they deviate, is very spread out. This one is not. Data B, data set B, dili siya spread out. It's compact and it's symmetrical. The mean is the same. If you add this and this 3, 15, tulo ka 15, tulo ka 16, and isa ka 17. If you add all that, that's the mean is still 15.5, but the standard deviation, if you apply this formula, would be different. It's now only 0.9258 because they are compact. While data C here, most of the elements in the data set are farther spread out. If you add tulo ka 11 plus isa ka 12 plus isa ka 19 and tulo ka 20, the mean would still be 15.5, but the standard deviation, they are spread out, very much spread out further, lagyo sila, because the standard deviation, if you apply this formula, is 4.57. Standard deviation can be thought of as a measure of distance from the mean, how far the distance of the elements are from the mean. You notice here, data B, wala na mag-1 ang iyang standard deviation kay compact sila, dugol sila. Kini lagi sila ang center ani na diha. Kini ang more or less ang center ani naman po diha. But they are spread out. So that's standard deviation. Now we have an example here. Boydson Shipping Company. Boydson Shipping Company owns and operates a fleet of tanker ships that carry commodities between the countries of the world. In the past 6 months, the company has had 7 contracts that called for shipments between Vancouver, Canada, and London, England. For many reasons, the travel time varies between these two locations. The scheduling manager is interested in knowing the variance and standard deviation in shipping times for these 7 shipments. To find these values, he can follow these steps. As always, step 1, collect the data for the population. The shipping times are shown as follows. X is the shipping weeks that refers to number of weeks when the commodities are shipped, how long it took, how many weeks. In this case, the population data is 5. This is 5 weeks, 7 weeks, 5 weeks, 9 weeks, 7 weeks, 4 weeks, 6 weeks. Now step 2, select equation 3.10 to find the population variance. This is population because it involves all the data that they have, not just a sample. They have in the past 6 months, the company has had 7 contracts. That's all they have. These data are not, it's not a sample, but the entire population. Step 2, select equation 3.10 to find the equation variance. This one. Now step 3, add the x values and square the sum. 5, these numbers are the weeks, number of weeks for the delivery of shipments. 5 plus 7 plus 5 plus 9 plus 7 plus 4 plus 6, which is equal to 43. And 43, if we square it, that is 1,849. Now step number 4, square each of the x values and sum these squares. Ini siya ang sum lang sa value ang square sa step 3. Sa step 4, each of the values are squared and then totaled or summed. In this case, 5 is squared plus 7 squared plus 5 squared plus 9 squared plus 7 squared plus 4 squared and plus 6 squared, which is 281. Now step 5, compute the population variance. Now what is the population variance? This formula, we just substitute what is now known from step 4. The sum of the squares is 281 minus the x values and the square of the sum. The square of the sum, this one is the square sum of the squares. Divide by 7 and all over divide by 7. The variance is in units squared. So in this example, the population variance is 2.4082 weeks squared. Step 6, calculate the standard deviation as the square root of the variance. Now here, square root of the variance is 1.5518 weeks. Thus, the standard deviation for the number of shipping weeks between Vancouver and London for the 7 shipments is 1.5518 weeks. 1.5518 weeks. Computing a sample variance and standard deviation. That was population. This one, what we have was population. because these 7 shipments were all that they had, not a sample. And that's how we calculated. This one is a sample variance and standard deviation. From Zenith Systems. The quality control manager at Zenith Systems, a manufacturer of equipment used in the oil and gas drilling business, recently performed 10 independent tests on parts attached to the equipment the company makes. In each test, 100 parts were examined and the number of defective parts recorded. The tests can be considered to be samples of all possible tests in 100 parts that could be conducted. To fully analyze the data, the manager can calculate the sample variance and sample standard deviation using the following steps. Step 1. Step 1. Select the sample and record the data for the variable of interest. Here is the sample. Step 2. Select either equation 3.12 or equation 3.13 to compute the sample variance. If we use equation 3.2 here, this will be the equation. Step 3, compute the mean. The sample mean number of defectives is, the mean is equals the sum of all x divided by n, or sum of all x is 30 divided by 10. The mean is 3.0. Step 4. Determine the sum of the squared deviations of each x value from the mean. The mean of all the x values. The tests is 1 to 10 defectives, which are the x 4, 7, 1, 0, 5, 0, 3, 2, 6, 2, which is 30. Now, standard deviation, x minus the mean, because we want to determine how far it is from the center. The mean is 3, so 4 minus 3 is 1, 7 minus 3 is 4, 1 minus 3 is negative 2, 0 minus 3 is negative 3, 5 minus 3 is 2, 0 minus 3 is minus negative 3, 3 minus 3 is 0, 2 minus the mean 3 is negative 1, 6 minus 3 is 3, and 2 minus 3 is negative 1. Now, we have here the square of sum. You just square this number. 1, if you multiply 1 by itself, it's still 1. But if you multiply 4 by itself, it's 16. If you multiply a negative 2 by itself, it's positive 4. If you multiply negative 3 by itself, it's 9. If you multiply 2 by itself, that's 4. You multiply negative 3, it's 9. You multiply 0 by itself, is 0. multiply negative 1 by itself is positive 1. 3 square is 9, and minus 1 squared is positive 1. Now, if you add this, if you sum that, that's 0. Here, if you sum this, that's 54. Now, step 5. Compute the sample variance using equation 3.12, which is this one. 54 minus 9 equals, and divided by 9 equals 6. The sample variance is measured in squared units. Thus, the variance in this example is 6 defectives squared. In step 6, compute the sample standard deviation by taking the square root of the variance, which is the equation 3.14, which is this. By substitution, that one, and this reduced to square of 6, which is square of 6 is 2.4495 defects, or more or less duhag ko nga. This sample standard deviation measures the variation in the sample data for number of defects per sample. Now, the coefficient of variation. Now this is coefficient of variation. This measures relative variation. Relative, how relative? It's always in percentage and shows variation relative to mean. Relative to the mean, to the center of the data set. And it is used to compare two or more sets of data measured in different units. And as always, there is the population coefficient of variance, and there is the sample coefficient of variance. Basically the same except for the symbol. This is the mean for the sample. This is the mean for the population, the symbol. Now, comparing coefficient of variation, say we have stock A and stock B. Stocks are stocks are actually like your investment in a company. When you buy a stocks of a company, you own part of the company. Okay, I hope you are familiar. For example, Jollibee is owned by many people. Those who buy the stock of Jollibee. The stock is used for capital investment. Here, stock A, the average price last year was $50. And its standard deviation is only $5, given this formula multiplied by 100%, $5 divided by 50, that's multiplied by 100, that's only 10%. While stock B, The average price last year, because prices would vary from year to year. Stock standard deviation is 5. The standard deviation is 5, but the price is different. This is 100, that is 50. Using this formula for stock, same formula for the both of them, the result is only 5%, the coefficient of variation. That is, both stocks, CA and CB, have the same standard deviation, $5. Mulahi sila, differ sila from the mean. But stock B is less variable, dili kayo siya mo vary, di kayo siya mo change relative to its price, because it's only 5%. Now, chapter summary. We have described so far the measures of center and location, or this the central tendency where the center of a data set may be located using the mean, the median, and the mode. We have discussed also percentiles and quartiles, what they are. Percentiles are percents, and quartiles are quarters, 1/4. We have described also measure of variation. This refers to these measure of variations as range, interquartile range, variance, standard deviation, and coefficient of variations. Class, that's the end of lecture 6, and if you have questions, please write them down and ask during our face-to-face class. And that would be all for now, and